So how about so we have a serving layer, we can query the file storage, we can move our sources using Spark. But how do we handle user security, and how do we orchestrate everything? How does that fit in?
Well, we've got quite the things that across the cluster that will show you to how we can orchestrate things, how we can deal with security, operate this entire cluster, right?
Okay.
But first, I want to discuss quickly about real time, because what we've seen here is mainly batch mode yet, right? Except Spark, because Spark can do Spark streaming. So that's Spark is, as Jeff said, it's really good. You can do quite a lot of things with it. But here we also have some other products that are really designed with real time in mind. So you've got Flink that lets you create a sink from your data source, and you'll create a sink that will then feed your other application. It can feed Kafka or Spark streaming or something like that. But that's really where you want to have all your data pouring in, and then you'll use you'll build a pipeline after that, right? But that's your source of data usually. And then you've got Kafka, which is a messaging tool, distributed messaging tool.
Not anymore. It is also a SQL engine. It's also a million other things that they want to try to sell you on as well, right? So we can talk about.
Yeah, it can be your data warehouse. That's what they say.
Oh, that's right. It's your data warehouse.
Yeah.
Right. So KSQL came out. So the ability to then do a SQL query against the Kafka cluster, which I still have trouble wrapping my head around, like what that even means, because as Jerome said, Kafka was originally built upon messages and not losing a message. So Kafka has a guaranteed at least once delivery, right? Which means you have duplicates in a Kafka cluster. Like you're gonna, if your message will make it no matter what, but like 4 of them might make it. We don't know. It could be 10, it could be 4, it could be 1. We're not sure. And then when you start to design it, and they've added this since the original Kafka clusters were starting to be built, they've added a one and only one delivery mechanism. But it's a huge performance hit, because obviously Kafka internally is then doing the same thing that your Java program at the other end of your Kafka topic is going to be doing, which is going through and deduplicating your data, right? And so, there are, Kafka is one of those funny technologies. I mean, when you look at these, right? Spark tried to boil the ocean. Hive tried to boil the ocean. Even Flink to some extent, Kafka for sure. So a lot of these different companies, they started as a third-party technology or an open source technology, and they were incorporated. Yeah. So Confluence was built up around it, right? Databricks was built up around Spark. So these companies were built around it, and then what they do, right? They try to monetize these open source technologies as much as they can. They build enterprise versions, and they try to do more than they probably should.
Support,
Yep. So from a real-time perspective, I think we talked about movement. Kafka can do ETL, Flink can do ETL, Spark streaming, great for ETL. And then the other side of it is how you serve it out. That's the majority of that is going to be Kafka, right? Kafka is great for that serving layer. We see it as, even if you're not doing real time, we see Kafka a lot of times as a great serving layer, because you can subscribe to different topics that matter to you and nothing else. Don't subscribe to the stuff that you don't care about.
And there are so many connectors out there that
that's right.
Your technology is probably already existing.
It's pretty easy.
Right?
It used to be a lot harder than it is today, right? So Kafka is something that we see a lot.
Yeah.
We'll be remiss not to mention something like Golden Gate, right? So Golden Gate is a great technology that most of our listeners are going to understand is like obviously a very famous Oracle piece that has big data connectors, and one of the most important ones that really fits in with the Golden Gate paradigm is Kafka. Right? So we have connectors into Hive, we have connectors into HDFS. You can dump your Golden Gate data directly into HDFS. You can dump it directly into Oracle Cloud or S3, right, using the S3 APIs. So they have those as well, but I think the most interesting one is Kafka, because you're in that kind of real-time mode and you're passing transactions into Kafka. Kafka never loses anything, always remembers it. It's that same kind of really hardened, guaranteed delivery kind of paradigm that Golden Gate thrives on, and that Golden Gate's been known for, that you can then translate downstream into a big data environment.
Yeah. Okay. I know your question about security and
Orchestration, yeah.
orchestration.
And
Everything,
honestly,
right?
this is a big one because it's the downfall of Hadoop clusters.
Yeah.
Right? We don't see Hadoop clusters anymore. We don't see any organizations. It's very rare to see organizations trying to run a managed Hadoop for customers that at least some of the stuff isn't customer owned, right? So fully managed Hadoop, I mean, right? So certainly we see these like halfway efforts, and certainly Oracle has them. Our competitors have them, where your customer has some access to the administration of the cluster and some ownership of the administration of the cluster, and then we own the disks, we own the updates, we own certain things, but we don't own everything, right? The black box Hadoop cluster dream, that thing died because it's too hard.
It is.
There's so much customization. It's so hard to keep these things up. It's very expensive.
Yeah, all that layer here at the bottom is actually hard. I really like the first one because when they created all these all these tools, right? All this Hadoop ecosystem, most of these tools took a name of an animal as the name of the product, right? So what they use to check the status of all your tools, if it's running or not, all these pieces of software, they call that zookeeper because they think it's just a zoo. It's a massive zoo. You've got so many animals, a lot of nodes and things like that. And so zookeeper is there to help you check what is up, what is not, what is wrong with all this stuff, how you can scale them and things like that. So it's really that. I just like the name. I really like it. Yeah. So that's for Zookeeper, and then Uzi is there as an orchestration tool and scheduling tool. You might have seen it in ODI. Actually, you can also have an Uzi agent instead of the normal ODI agent if you're doing big data. So that's what Uzi is, orchestration.
And the another huge thing that I've seen in my personal experience working with customers in big data is resource management issues, right? So I won't mention the customer's name, but we did have a customer that was running a bunch of third-party data science jobs on a Hadoop cluster that was managed by Yarn. And so Yarn is a resource manager. There's two prevalent resource managers. There's Yarn and there's Mesos. Mesos you'll see more in like a non-Hadoop environment, some kind of Elastic Spark environment, some kind of data science tool set. Any clustered compute Mesos can support. You see it a lot with Dockers and Kubernetes, right? So you'll see Docker and Kubernetes clusters out there, and you'll have a Mesos layer on there managing their resources, their virtual resources as well. So you'll see it there. It's both great technologies. Yarn is just very Hadoop specific, but this particular customer had a Yarn managed cluster, which means Yarn owns every bit and byte of RAM and hardware and storage on that cluster, and is working on its own to manage these things, managing all the CPU, all the RAM, all the storage. And they were running jobs outside of Yarn that were insanely CPU and RAM intensive. And so the chances of doing that for over a long period of time and not getting some kind of gridlock is very low. And to this customer's credit, they didn't really have an issue with it, which is still damn impressive for me, like years and years later. But so I guess the next big problem is resource management, because you got to remember you're working on a distributed cluster, and something like Spark wants to see all of, obviously your HDFSs and your HBases and all these technologies are looking at the storage of all the nodes, right? So you have a lot of storage. You're looking at storage as a giant block across all these nodes. But then these new technologies came out to make things faster, and what did they want? They wanted blocks of RAM. So now you have all the memory across the entire cluster is being consolidated and leveraged by something like Spark, for example. And so it became a very important part of a Hadoop cluster to configure and set up your resource management. And then I guess the last thing is security.
Yeah,
the big one. How do I keep somebody from logging in? And the sad part, I would say, is the amount of people that just have admin on their Hadoop cluster, and anyone just logs in and does whatever they want with the same account, it's probably the vast majority of Hadoop cluster.
I think the complexity of the Hadoop cluster is the best security in itself, because nobody
That's
wants
right.
to log in it, and nobody knows what to do
90%
once
of the
they're
people have
logged
no
in.
idea how to even log in. Yeah.
But if you want to actually put security, the main solution we see out there is Kerberos. Kerberos also isn't Hadoop based, so you can have that running outside of
Yeah, it's like a
Hadoop, right?
Microsoft. It's like originally was like a Microsoft technology for just distributed computing or really securing anything on like a network, right? But these policies, these Kerberos policies, they kind of drive the security in most Hadoop environments. There's a central like so called the KDC, where everyone authenticates against it. But there's lessons learned, right? You got to make sure that it's built to be local. A lot of the cloud deployments of Hadoop will have like a centralized KDC in a data center that's got a ping of 300, and all the amount of chat that goes across that is very high. So you'll see latency problems and stuff. So Kerberos is definitely not the easiest thing to work with, and causes a lot of pain over the years for these customers.
I guess it's already good if you manage to set up a Hadoop cluster. But then there's an extra step if you want to set up a Kerberized Hadoop cluster. That's a much higher difficulty. The complexity is really high, but it gives you a lot of specific access. You can really be specific in what you give. You can to relate to our database world. You can give column access or row access to anyone, to anything, right? So. It's really deep down.
Not in Kerberos. So we don't actually have the icon here, but that's Ranger. So like.
Oh yeah, right. Yeah, it is Ranger.
So Kerberos is going to give you like your user access to the nodes. It's going to give you access to the files, systems in general. But to do the fine grained like data management, data access.
Yeah, right.
Like Ranger comes in.
Mix these
right?
two.
So there's also Sentry. Sentry is dead now after we'll talk a little bit more about the kind of deployment options, but two of the biggest Hadoop providers combined together, and they went with Ranger as their go forward solution, which is good because it's better. But Ranger is kind of we should have probably put that on here, but that one is the really kind of go to for that distributed row column level low level access fidelity access control for users and data. Yeah.
Cool.
So any questions, Matthew? I mean, I don't think we've really thrown that much information at you so far, so I feel like you're ready to go be a Hadoop admin at this point.
I think it's very enlightening. Coming from my traditional background, I think I have a better grasp of a better varnish, I would say, on.
So let me ask you this: so from a SaaS and FAW perspective, where do you see, like when we're looking at all this capabilities and these different technologies, do you see any kind of synergy, or do you see any opportunities here that an FAW customer might be able to leverage some of these things, like for example, data flow Spark service or something like that? Can you think of any kind of use cases or something off the top of your head where these might be useful?
Kafka. I think Kafka would be something that would be very interesting. Of the ability to be able to stream live data from
so I think that's something we hear a lot, right, from our from our SaaS customers, is to have a little bit more of a higher speed, pseudo real time type of view of the data as it comes in, not like the nightly batch kind of deal. That's awesome.
Also, once you've got your data into Kafka, you can spread it wherever you want, so that's quite easy, right? You can read
the Kafka technology is super interesting. We might have to do a whole podcast on it by itself, but it's super high fidelity. It's very interesting. It will store infinite amounts of history, right? It's a great set of tools.
Yeah, we'll do another podcast on that and invite Robin from Confluent. Yeah.
Okay, cool. That would be awesome. Yeah.
Cool. Okay, so that's just a subset, Mathieu. That's just a subset of the numerous tools that exist in the big data world.
Some of the most popular ones.
We just put you the one. Yeah, we put you the ones that were the most popular or survived, or some of the ones that were massively adopted out there. But there are a lot of other things.
Thanks a lot for joining us for this segment of the Cloudology podcast. For our next part, please check out www.ateam-oracle.com. See you next time.